Okay, guys, shall we start today's class? Shall we?
Yes, sir.
Good. So I guess you have a session after this at 10 o'clock, isn't it?
Yes, sir.
So for that, I would leave you 10 to 15 minutes early, but provided please do concentrate for this next half an hour or 35 minutes odd. Okay, it's very important. Okay, so understood the Rankine cycle in the previous class. So how exactly is the Rankine cycle? Yes. Any doubts in the Rankine cycle yesterday?
No, sir.
No, sir.
Okay. So today we will be discussing how exactly, so if I vary some of the parameters, say for example, the boiler pressure, or if I say the condenser pressure or the maximum temperature. So if I vary certain parameters, how exactly it affects the efficiency or the work output. So that particular concepts we'll be dealing today. For example, if you look at this particular TS diagram, I told you all these are isobars, isn't it? Like this. Just a minute. Okay, fine. So all these are isobars. So this is at one particular pressure. Not only this, all this, and this will occur only at one single pressure. So all these lines are there, no? Whichever I highlighted, all this are at a single pressure. Okay. So for example, even this is also at the same pressure. Now, if I draw a straight line within these two curves, all this would be a isobars. Isobars in the sense the pressure at all these points would be equal. For example, the pressure at A would be equal to pressure at 4. That would be equal to pressure at B, and same pressure would be at 1 also. All these are isobars, I can say. For example, this also 3 to 2. Pressure at 3 would be equal to pressure at 2. Got it? Clear?
Yes, sir.
Now, look here. So there are two different pressures which I deal every time. Okay, one pressure is known as the boiler pressure. The one is known as the boiler pressure, and second one is known as the condenser pressure. Okay, can you identify which one is the boiler pressure and which one is condenser pressure? Anyone?
A to B is the boiler, condenser is 3 to 2 or 2 to
Exactly.
3.
So boiler pressure, I can write it as P4, which is equal to PA, which is equal to PB, which is equal to P1. So all these are nothing but the boiler pressure. Since the pressure remains constant, I can take P4 equal to PA equal to PB equal to P1. Similarly, when I talk about the condenser pressure, I can say condenser pressure is nothing but P3, which is also equal to P2, which is also equal to P2 dash, and so on. Getting my point? Understood? So boiler pressure is which pressure? Suppose if I talk about the boiler pressure, PA is boiler pressure, PB is boiler pressure, because all those are same values. I can take any one of those. Similarly, with case for 3 and 2, I can take P3 or P2. Both have the same values. So that particular pressure, I can consider it as a condenser pressure. Clear with these? Understood? Yes or no?
Understood, sir.
Good. So next, you have understood what is a boiler pressure. You have understood what is condenser pressure. So boiler pressure is this particular line and the condenser pressure is this particular line. You have understood that. Now, what if I increase the boiler pressure? Normally, my Rankine cycle was running something like this: 1 to 2, 2 to 3, 4 to 3 to 4, 4 to A to B, and B to 1. This was the normal running Rankine cycle. Now, what I have done is I have increased the boiler pressure from A dash, A to B to A dash to B dash. Now, what happens? From 4, it has increased to A dash, next to B dash, next to 1 dash, and again it has come to 2 dash and reached the 3. Okay, so H1 to 2 is the turbine work output, with a normal Rankine cycle. H1 dash minus H2 dash is the turbine work output when I increased the boiler pressure. Now, just by looking at the diagram, can you say which one has got the greater work output?
So after increase.
Yes or no? So if you go on increasing the boiler pressure, what happens to your work output?
Increases.
That's what. So please read this one.
So what happens to the efficiency, sir? It will decrease,
Efficiency,
no?
the work output, if work output increases, what happens to the efficiency? With the same heat input,
Decreases.
heat input, you're not varying anything. Heat input is same.
Okay,
But
okay. Just
inevitably,
pressure you are
you're
increasing.
increasing the output. Only
Yeah.
pressure you're increasing.
Yeah, okay.
Heat input is same. With the same input, you're getting maximum output. So what happens to the efficiency?
It remains same.
Increases. So please read this line, Lucky. Therefore, Lucky, can you read
Yeah,
this?
sir. Yeah.
Please read
Yeah.
this.
Increasing the
Therefore,
boiler pressure with increase in the thermal efficiency in the after Rankine cycle.
so
Yeah,
if
sir.
you increase the boiler pressure, what
Yeah.
happens to the thermal
Efficiency also
efficiency? So that is the conclusive statement. This is all the explanation what I have given, man.
Okay,
Okay.
sir. Yeah.
So with increase in the boiler pressure, what happens to the efficiency? Efficiency also increases. Yes. So what you have to do is, if in case, how the questions would be asked in the examination, they will ask, discuss the effect of boiler pressure on the efficiency or the parameters of the Rankine cycle. If they ask such, then you have to write all these from here to here, including conclusive statement. Understood? With the same explanation what I have given. That is more than enough. If you write in your own words also, no issue. Clear with this? Boiler pressure, effect of boiler pressure. Any doubts?
No, sir.
Any doubt? Okay, good. So next, we will move on to the condenser pressure. Okay, now what I will do, I will move to the condenser pressure. So the normal running Rankine cycle is this: 1 to 2. Please do observe carefully. 1 to 2, 2 to 3, 3 to 4, 4 to A to B, and B to 1. So this is the normal running Rankine cycle. Now, if I increase the condenser pressure, where is the condenser pressure? Whether it is from A to B or 3 to 2. Condenser pressure.
3 to 2. 3 to 2.
3 to 2. So, if this particular value of 3 to 2, if I increase this, from where did I increase? From 3 to 2, I have increased it to 3 dash to 2 dash. Okay, 3 dash to 2 dash. Now, for the normal running Rankine cycle, the work output was this much, which is H1 minus of H2. When you increase the condenser pressure, the work output became this much, which is H1 dash minus H2 dash. So what is your inference? Anyone? I would be very glad if you say me the inference from this. What happens if I increase my condenser pressure?
Work output decreases.
Work output decreases. Excellent. And what about thermal efficiency?
Decreases.
Decreases.
Decreases. Same thing is being written here. Narendra, can you just read this?
Increasing condenser pressure. Therefore, increasing condenser pressure will decrease the thermal efficiency. Decrease thermal efficiency of the Rankine cycle.
Understood? Any doubts here? Any doubts? Any doubts? Any doubts in this?
No, sir.
Good. Next, superheating temperature, man. Superheating temperature. What do you mean by superheating temperature? Can anyone identify which is superheating temperature? Whether it is state 1, whether
B1.
it is state 2.
B21.
B2, sir.
B21 is superheating process. 1 minute. Okay. So yes, which is the superheating temperature? Whether it is state 4, state 3, state 2 or state 1?
State 1.
Okay. Now this is very easy. Now superheating temperature, if I increase, now I have increased up to 1 dash. What happens to the work output just by looking at the diagram? Can you even say?
Increases.
Increases. What happens to the efficiency?
Increases.
That's it. So that is the inference what I have drawn here. Can you read, Aditya?
Increasing superheating temperature will increase the thermal efficiency of the Rankine cycle.
Understood. So these are the 3 different parameters through which you can play with. One is the boiler pressure, second one is the condenser pressure, and third one is the superheating temperature. So let us have a quick revision now. Okay. So what happens when I increase the boiler pressure? You have to tell me with regard to the thermal efficiency of a cycle. What happens if I increase the boiler pressure? Thermal efficiency increases or decreases?
Increases.
Increases. Everyone should answer this. Everyone should answer. What happens when I increase the condenser pressure?
Thermal efficiency decreases.
Thermal efficiency decreases. Only two are replying. What about remaining? What happens when I increase the superheating temperature?
Thermal efficiency increases.
Increases.
Thermal efficiency increases. I guess it is clear now. Now, how many of you remember the regeneration, reheating and intercooling in Brayton cycle? Yes, the same concepts, the methods through which I can increase the efficiency or the work output, of a cycle, of a Brayton cycle, where three methods, isn't it? The one is regeneration, second one is intercooling, and third one is reheating. Now, where did you apply the intercooling? Anyone? Where did you apply the intercooling? Whether you applied in between the compressors or you applied in between the turbines. Where you applied? Intercooling I'm talking about.
In between compressors.
In between the compressors. So if you apply in between the compressors, intercooling can be achieved. Do I have a compressor in case of a Rankine cycle?
No.
No.
We don't have a compressor in case of a Rankine cycle. So can I apply intercooling here?
No.
No.
Definitely no. So intercooling is vanished away. It is gone. Only two methods are there. One is regeneration and other one is reheating. So regeneration, you can just observe here. What happens in the regeneration is, okay, the same thing. The normal running will be first economizer. It will pass on to the economizer, next to the boiler, next to the superheater. So once high pressure, high temperature steam is being obtained here, it would pass on to the turbine. It would expand completely up to 2. This is normal cycle I'm talking about. Normal cycle. Okay. It will expand completely, and after expansion, it is sent to the condenser where it will convert back into the water. Then that particular thing would be pumped back to the boiler. So this is what was happening in case of a normal Rankine cycle. Now, what is regeneration in case of a Rankine cycle? What I do is same thing. The pumped liquid is sent to the economizer, next to the boiler, next to the superheater. So next it is sent to a turbine where it allowed to expand partially. Only 50%. Think only 50% is allowed to expand here. And again, after expansion, whatever is there, that is again sent back to the heating zone. Again, it is sent back to the heating zone through a feed water heater. It is not allowed to expand completely. It is allowed to expand partially. ಅರ್ಧದಲ್ಲೇ ಅದನ್ನು ನಿಲ್ಲಿಸ್ಬಿಟ್ಟು ಔಟ್ಪುಟ್ ಏನಿದೆ ಅದನ್ನು ಪುನಃ ನಾವೇನ್ ಮಾಡ್ತೇವೆ, ವಾಪಸ್ ಕಳಿಸ್ತೇವೆ ಹೀಟಿಂಗ್ ಝೋನಿಗೆ. ಹೇಗೆ ಕಳಿಸ್ತೇವೆ ವಾಪಸ್ ಹೀಟಿಂಗ್ ಝೋನಿಗೆ? ಬೈ ದ ಹೆಲ್ಪ್ ಆಫ್ ಫೀಡ್ ವಾಟರ್ ಹೀಟರ್. Understood, everyone? Understood? So this is how the regeneration happens. It is a complex cycle. Some of the things will be rotating here and some would be rotating like this. Getting my point? Both the things are possible. Some of the steam can come back through the feed water heater, and again it can come and reheat here. Some of the steam would completely expand and come back through the condenser. All these are the possibilities. Now, if 1 kg, understand this very carefully, if 1 kg of steam is being sent here, if 1 kg of steam is being sent at the inlet of the turbine, after partial expansion, if m1 amount of steam is being sent back for the regeneration. What is the remaining steam which is undergoing second stage of expansion?
Condensation.
How much amount of steam is going the condensation?
1 minus M1.
1 minus M1.
Excellent, guys. It is 1 minus of M1 amount of fluid, amount of steam is undergoing next stage of expansion. Thereby, the same fluid is going into the condenser, which is 1 minus M1. Understood? Understood this concept?
Yes, sir.
Yes, sir.
This is very, very important. Very, very important.
Yes, sir.
Okay. So basically there are two pumps, which one is WP1 and WB2. Okay, two pumping works are there. One pumping work will grab the water from the condenser and move to the feed water heater. And it will move to the feed water heater. Feed water heater, you are heating up the things, man, here. What basically you are doing in a feed water heater is you are heating the water which is coming. For example, one minute. See, these concepts are very interesting, guys. Okay. So once again, I am revising these things up. So if 1 kg of steam is being entered, partially expanded 1 kg, out of 1 kg, M1 amount of fluid is being sent back for the regeneration. So how much left over for the next stage of expansion? How much left over for the next stage of expansion?
1 minus M1.
1 minus M1. So same fluid will come and reach here. This is also 1 minus M1. Correct? Correct?
Yes, sir.
Please do respond, guys.
Yes,
This is
sir.
very, very important to be understood. I told you there are, what can I say? Two different works. So this is 1 minus M1. This is M1. Two different pumping works are there. WP1 is the first pumping work. WP2 is a second pumping work. What happens in a feed water heater? I was discussing feed water heater. What happens, just try to understand this. Now, whatever the water after the condenser is coming here, understanding? Whatever the water is coming here, okay, this is to be at the lower temperature. Correct? Now, one more fluid is coming from here in between the expansion. So think this is the fluid A, this is fluid B. So which one would be at a higher temperature? Whether fluid A will be at higher temperature or whether fluid B will be at a higher temperature.
Fluid A.
Fluid A will be at the higher temperature, correct? So this higher temperature fluid and this lower temperature fluid will mix. Correct? When mixing, whether the temperature of this lower temperature fluid will be increased?
Yes, sir.
Yes, sir.
Yes or no? So this is how you are increasing the temperature of the feed water. Feed water in the sense, the water which you are supplying to the boiler. Understanding? So how we are going to increase the temperature of the feed water? In the middle of the regeneration, in the middle of the expansion, some amount of steam, you're taking it out. Some amount of steam, you're taking it out. The heat of the steam, the temperature of this intermediate steam are used to heat the feed water. Understood? Understood or not?
Yes, sir.
So this is how the temperature would get increased now. Okay, there are some formulas, I guess. This is the TS diagram you can observe there. Okay. Now, I told you how many pumping works are there. How many pumping works are there? How many pumping works are there? Anyone?
2.
2 pumping works are there. So how will you calculate the pumping work? It is difference in the enthalpy. First pumping work happens from state 3 to 4. Second pumping work happens from state 6 to 7. Okay. So how will you calculate the pumping work? Work in the sense that is initial minus final. So from 3
H3
to
minus
4.
H4.
Excellent. So it is H3 minus of H4. Okay. Here, how will you calculate WP2?
H6 minus H7.
H6 minus of H7. Now you see, whatever the unit should be having, you have to multiply the mass flow rate into enthalpy. You have to multiply what? You have to multiply the mass flow rate into enthalpy. Now you give me the values of WP1. WP1 is what? Mass flow rate. What is the amount of fluid which is flowing here? This is the amount of fluid which is flowing, which is this. So what is the amount of fluid which is flowing?
1 minus M1.
M1 into what is the enthalpy difference?
H3 minus H4.
So this completes the formula to calculate the value of WP1. Understood? Now you come for WP2. What is the fluid which is flowing? What is the fluid which is flowing?
M1.
M1 is the fluid which is flowing. So M1 into
Sir.
it is H6 minus H7.
Sir, ಅದು ಮಿಕ್ಸ್ ಆಗ್ತಿಲ್ಲ ಸರ್ 1 minus M1 ಮತ್ತೆ M1.
ಜಸ್ಟ್ ಹೀಟ್ ಆಗ್ತದೆ ಅಷ್ಟೇ, ಹೀಟ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗ್ತದೆ. ಮಿಕ್ಸ್ ಅಂತಂದ್ರೆ ಹೀಟ್ ಎಕ್ಸ್ಚೇಂಜರ್ ಅಲ್ಲಿ ಹೇಗಾಗ್ತದೆ? ಹೀಟ್ ಎಕ್ಸ್ಚೇಂಜರ್ ಹೇಗೆ ವರ್ಕ್ ಆಗ್ತದೆ? ಈ ತರ ಒಂದು ಫ್ಲೂಯಿಡ್ ಇರ್ತದೆ. ಜಸ್ಟ್ ಅ ಮಿನಿಟ್, ಐ ವಿಲ್ ಡ್ರಾ ನೀಟ್ಲಿ. ಓಕೆ, ಇನ್ನ ಒಂದು ಕೋಲ್ಡ್ ಫ್ಲೂಯಿಡ್ ಈ ತರ ಇರ್ತದೆ. ಓಕೆ, ಸೊ ಹೀಟ್ ಹಾಟ್ ಫ್ಲೂಯಿಡ್ ಇಂದ ಕೋಲ್ಡ್ ಫ್ಲೂಯಿಡ್ ಗೆ ಹೀಟ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗುತ್ತೆ ಅಷ್ಟೇ. ಓಕೆ, ಕ್ಲಿಯರ್ ಆಯ್ತಾ? ಸೊ ದಿಸ್ ಈಸ್ ದ ಪಾಯಿಂಟ್. Now you look into the TS diagram. Please do observe carefully. It is very clear in the TS diagram. 7 to A is your heat added where? 7 to A is the heat added where? Anyone? In economizer? Correct. In economizer. Economizer. Very good. A to B is the heat added where? Boiler. Everyone should respond now. This is very important because this covers entire thing. B to 1 is the heat added where?
Superheater.
So from all this point of view, there would be 1 kg of fluid which is coming here. Even here also, it would be how much? 1 kg of fluid. 1 kg of fluid. Correct? From state 1 to state 5, some amount of fluid will be expanded, which is 1 kilogram. Okay, out of which M1 amount of fluid will be sent back for the regeneration. Correct? And remaining fluid, which is this, how much is the remaining fluid? How much is the remaining fluid? 1 minus
M1.
M1 would be sent back to the condenser here. Correct? ಅರ್ಥ ಆಗ್ತಾ ಇದೆನಾ?
Yes, sir.
ಈಗ ನೋಡ್ರಿ, 2 ಪಂಪಿಂಗ್ ವರ್ಕ್ ಯಾವುದು? 3 to 4 is first pumping work, 6 to 7 is the second pumping work. Now how will you calculate pumping work? Anyone? WP1. I would
1
just take
minus
the red
M1
color.
into
WP1, yes, 1 minus M1 into
H3 minus
H3
H2.
minus H4.
H2.
H2.
H4. Yeah, H4.
WP2, second pumping work ಯಾವುದು? This is the second pumping work. How will you
M1
calculate
into
that?
M1
Very
into
good. M1 into
H6 minus H7.
H6 minus
H7.
H7. Next, what is the heat added, heat supplied here? Anyone? Heat supplied.
H6 minus H4.
H6 minus ಅದು ಫೀಡ್ ವಾಟರ್ ಹೀಟರ್ ಹೀಟ್, ಅದು ಇಟ್ ಇಸ್ ಫೀಡ್ ವಾಟರ್ ಹೀಟರ್. Heat added ಇಲ್ಲಿ ಇಲ್ಲಲ್ಲ. So heat added is a combination of 3. Give 7 to A, give A to B, correct? Give B to 1. ಈಗ ಹೇಳಿ, heat added 7 to A ಏನು?
HA minus H7.
HA minus H7. Should I multiply something with the mass flow rate? If I multiply also, it would be 1 again. ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
ಮಾಸ್ ಫ್ಲೋ ರೇಟ್ ನಾನು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದ್ರು ಸಹ ಅಗೇನ್ 1 ಬರುತ್ತೆ ಅದು. ಈಗ HA to B ಹೇಳಿ, QA to B.
HB minus HA.
HB minus of HA. Next QB to 1.
H1 minus HB.
H1 minus of HB. Now, ಈಗ ಟರ್ಬೈನ್ ವರ್ಕ್ ಚಾಲೆಂಜಿಂಗ್ ಅಪ್ಪ. ಯಾರು ಹೇಳ್ತೀರಾ ನೋಡೋಣ. ಟರ್ಬೈನ್ ವರ್ಕ್, which is this. It happens in 2 stages, guys. One with 1 kg per second of mass flow rate. Another expansion with 1 minus M1 amount of mass flow rate. How will you give me the turbine work output? Anyone?
1 into.
Very good. 1 into
H1 minus H5.
Excellent, Aditya. It is 1 into H1 minus of H5. ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ಆಯ್ತು ಅದು ಕೆಲಸ. ನೆಕ್ಸ್ಟ್ ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ
M1 into
M1 ಅಲ್ಲ, ಇದೇನಿದು? ಮಾಸ್ ಫ್ಲೋ ರೇಟ್ ಏನಿದೆ?
1 minus M1
ಪ್ಲಸ್ 1 minus M1 into
H5 minus H2.
H5 minus of H2 initial minus final. ಅರ್ಥ ಆಯ್ತಾ? Understood?
Yes, sir.
Very, very important. Very important. Okay. Now, can you give me the heat lost in the condenser? That is from 2 to 3, sorry. Heat lost in the condenser, anyone? Can you give me heat lost in the condenser?
1 minus M1 into
M1.
Excellent, Lucky. 1
H3
minus M1
minus
into
H3 minus H2.
excellent. Final minus initial. ಅರ್ಥ ಆಯ್ತಾ? ರೀಜನರೇಷನ್ ಎಲ್ರಿಗೂ ಇಂಟ್ರೆಸ್ಟಿಂಗ್ ಉಂಟಾ ಇದು?
Yes, sir.
ಈಗ ಸೇಮ್ ಥಿಂಗ್ ಇಲ್ಲಿ ಬರಿತಾ ಹೋಗ್ತೇವೆ ನಾವು. ನೋಡಿ, ಕರೆಕ್ಟ್. ಹೀಟ್ ಸಪ್ಲೈಡ್ 7 to 1 ಆಗ್ತದೆ. ನಾವು ಸ್ಪ್ಲಿಟ್ ಅಪ್ ಬರ್ದಿದ್ದೇವೆ, ಅವ್ನು ಡೈರೆಕ್ಟ್ ಆಗಿ H1 minus H7 ಬರ್ದಿದ್ದಾನೆ. ಅರ್ಥ ಆಯ್ತಾ ಇದು? ಕ್ಲಿಯರ್ ಆಯ್ತಾ ಇದು?
Yes, sir.
Yes, sir. Yes.
ಹೀಟ್ ರಿಜೆಕ್ಟೆಡ್. ಎಲ್ಲಪ್ಪ ಹೀಟ್ ರಿಜೆಕ್ಟ್ ಆಗೋದು? ಯಾವ ಪಾರ್ಟ್ ಅಲ್ಲಿ ಹೀಟ್ ರಿಜೆಕ್ಟೆಡ್ ಆಗೋದು?
Condenser ಅಲ್ಲಿ.
ಕಂಡೆನ್ಸರ್ ಅಲ್ಲಿ. ಸೊ ಕಂಡೆನ್ಸರ್ ಆಗೋದು ಯಾವ ಸ್ಟೇಟ್ ಇಂದ ಯಾವ ಸ್ಟೇಟಿಗೆ?
2 to 3.
So Q2 to 3. So this is the equation which you have given to me. Yes or no? 1 minus M1 into H3 minus H2. ಹೇಗೆ ಬಂತು ಅಂತ ಅರ್ಥ ಆಯ್ತಾ?
Yes, sir.
Now, efficiency of Rankine cycle. Output by input. Output is work output. From the first law of thermodynamics, heat flow is equal to work flow. That's why I take the total heat interaction divided by heat supplied. So total heat interaction in the sense it is QS plus QR. Heat supplied plus heat rejected. Okay. Heat supplied plus heat rejected. So heat supplied I have substituted the value. Heat rejected I have substituted the value. Heat supplied again have substituted the value. What happens when I supply H1 minus H7 to both the numerators? Here it would be 1 and it would be 1 minus M1 into H2 minus H3 divided by H1 minus H7. No need to remember this. Do not remember this. Okay. Just understand the concepts what I have told you. ನಾನು ಕಾನ್ಸೆಪ್ಟ್ ಹೇಳಿದ್ದನ್ನ ನಿಮಗೆ ಅರ್ಥ ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ ಎಲ್ಲ ಕುತ್ಕೊಂಡು ಬೈಹಾಟ್ ಮಾಡ್ಬೇಕಾಗ್ತದೆ ಇದನ್ನೆಲ್ಲ. ಬೈಹಾಟ್ ಮಾಡೋದು ಸುಲಭನಾ, ನಾನು ಹೇಳಿರೋ ಕಾನ್ಸೆಪ್ಟ್ ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳೋದು ಸುಲಭನಾ? Which one is easier? Concept, if you understand, that is easier. No need to remember all these formulas. No need to remember anything. Only the concepts, if you remember, output by input, you can calculate the things up. Examinationally, regenerative Rankine cycle, it is very, very important question. So in this particular question, he will be asking till here. So if you solve, calculate the efficiency, derive the efficiency up till here, you will get 10 marks in your examination. And remember, whatever the question is asked, this is with one feed water heater. How many feed water heaters are there? How many feed water heaters are there here?
One.
Only one. Now, look at this beauty. How is the figure?
Beautiful.
Beautiful, sir.
This is with how many feed water heaters?
4.
This is with 4 feed water heaters. I have seen in your question paper, max to max with 2 feed water heaters. Yabago 2012 alli with 3 feed water heaters. I have drawn it for 4 feed water heaters. ಏನು easily ನಂತರ ಮಜಾ draw ಮಾಡೋದು. Okay, we will discuss about this as we have discussed in the previous class with multiple feed water heaters in the next class. Okay, understood?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So what you do is, there is a small assignment, guys. What you have to do is, you have to just take a screenshot of this, draw this particular figure in your notes, and with this figure, you have to give me the TS diagram. ಅರ್ಥ ಆಯ್ತಾ? ಈ ಫಿಗರ್ ನ ನೋಡ್ಕೊಂಡು you have to draw me the TS diagram. Any doubt ಇದ್ರೆ ಕಾಲ್ ಮಾಡಿ. So you should draw this. Even the TS diagram ತೋರಿಸ್ತೀನಿ, ನಿಮಗೆ ಕನ್ಫ್ಯೂಸ್ ಆಗೋದು ಬೇಡ. Both these figures have to be drawn. Analysis of regenerative Rankine cycle with multiple feed water heaters. This particular diagram and ಈ diagram. ನೀಟಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಪ್ಯಾರಾಮೀಟರ್ ಅರ್ಥ ಮಾಡ್ಕೊಂತ ಕಾನ್ಸೆಪ್ಟ್ ನ ಕಲಿತಾ ಹಾಕಿ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಹೇಗಿದ್ರು ಡಿಸ್ಕಸ್ ಮಾಡುವ. ಕ್ಲಾಸ್ ವರ್ಕ್ ಅಂತ ಗೂಗಲ್ ಕ್ಲಾಸ್ ರೂಮ್ ಅಲ್ಲಿ ನಾನು ಇವತ್ತು ಒಂದು ಲಿಂಕ್ ಜನರೇಟ್ ಮಾಡ್ತೀನಿ. ಎವ್ರಿ ಒನ್ ಶುಡ್ ಸಬ್ಮಿಟ್ ಇಟ್. ಕ್ಲಿಯರ್?
ಇವತ್ತೇ ಸಬ್ಮಿಟ್ ಮಾಡಬೇಕು.
ಹೌದು, ಇವತ್ತು ಸಂಜೆ ಒಳಗಡೆ ಸಬ್ಮಿಟ್ ಮಾಡಿ. ಇವಾಗ ಅಂದ್ರೆ ಈಗಲೇ ಬೇಡ.
ಸಂಜೆ ಕ್ಲಾಸ್ ಉಂಟು ಸರ್, ಸಂಜೆ ತನಕ
ಕ್ಲಾಸ್ ಉಂಟಾ?
ಹಾ ಹೌದು ಸರ್, 4:30 ತನಕ ಕ್ಲಾಸ್ ಉಂಟು.
ಹಾರ್ಡ್ಲಿ ಟೇಕ್ಸ್ ಹಾಫ್ ಅನ್ ಅವರ್ ಕಣ. ಮ್ಯಾನೇಜ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ವಾ? ಸಂಜೆ 6 ಗಂಟೆಗೆ ಹಾಗೆ ಫ್ರೀ ಇದ್ದಾಗ.
ಸರ್ ಮಾಡ್ತೀನಿ ಸರ್.
ಯಾಕಂದ್ರೆ ಒಳ್ಳೇದಾಗ್ತದೆ, ಕಲಿತೀರಾ ಅಂತ ಅಷ್ಟೇ. ನಾನು ಯೂಶುವಲ್ ಅಸೈನ್ಮೆಂಟ್ ಕೊಡ್ತೀನಿ ಅಂದ್ರೆ.
ಸರಿ ಸರ್, ಮಾಡ್ತೇವೆ.
Please take the screen